Okay, number 35. Talking about a parabola. I've already written the information. Y equals x squared is either happy face or sad face. X equals ay squared is opening up to the left or opening up to the right. So I drew in my vertex right here, focus right here. Remember we said the focus was the pistil of our tulip. That's how we know it goes like this. And this gives us a ton of clues. Number one is a y equals ax squared. Number two, we know A has to be positive because it's a happy face. Number three, we know C is 3. That's this distance right here. We're going to put these two together and use A equals 1 over 4C to figure out what A is. So 4 times 3 is 12. Now I'm going to put this right here and we're done. Y equals 1/12 x squared. We figured out the equation of the parabola described in that problem. So I got number 36. The information is drawn. Y equals 4 is my soil, vertex 0, 2, and I can see that my letter C must be 2. Remember, we know that this tulip blossoms away from the soil, so immediately we know it's a y equals ax squared kind. Number 2, we know A is negative. Number 3, we know C is 2. If we put those two clues together, and we go A equals 1 over 4C, that'd be 1 over 4 times 2, which is 1/8, but it is negative. Now the twist is, notice the vertex is not 0, 0, it's been moved up 2. And up means there's been an adjustment to my y value. Up 2 is going to change this, and here's the grand finale. Y minus 2 equals negative 1/8 x squared. The reason there's no adjustment in the x is because the vertex didn't move left and it didn't move right. Number 37 says find the foci of the given ellipse. And if you recall, this must be a 1, which is your trigger. You know what to do to get started, and then you reduce it. So x squared all over 6 plus y squared all over 4 equals 1. Now because it's an ellipse, we know, and it's not telling us to graph it, it's saying find the foci, but we know it's going to be one of these. In other words, longer along the x-axis, because this is bigger than this. That makes our x-axis our major axis, which means our foci is going to be here and here. Now it's a very generic drawing, but that's going to help us because we're going to use the formula a squared minus b squared equals c squared. That's the formula you use for ellipses. A squared is 6, b squared is 4, and we get 2 equals c squared, so we go bada boom, bada bing, do the right thing. And because the center is 0, 0, I know we need to go this way the square root of 2 and that way the square root of 2. Because it's on the x-axis, it's going to be plus or minus the square root of 2, comma 0. That's why this little generic drawing kind of helps. Now this says hyperbola, find the foci. So notice this is my positive stuff and it's my x-axis, which means my hyperbola is going to look like this. Which means, once again, my foci will be on my x-axis, and that's important. But I'm going to go ahead and get it started by saying, okay, square root of 36. Actually, we don't really even need that because the formula is a squared plus b squared equals c squared. And once we get this truth in our head, we can go 36 plus 25 equals c squared. And that's going to be 61 equals c squared. Bada boom, bada bing, do the right thing. And once we realize that it's going to be a hyperbola like this, and our foci would end up being on our x-axis, we can say plus or minus the square root of 61, comma 0. And these can't be flipped, because if they were, then they'd be putting the foci on the wrong axis. Now we're going to get into some exponents for a while. And when I showed you guys this, I said ignore the negative and just deal with 25 to the 3/2 power. Remember, this is just the square root of 25, which is 5, and then we cube it, which is 125. Now the danger in forgetting that for a bit is you might forget it permanently, but that's the same thing as to the negative 1 power, which means put it where it ain't, and you're done. This rule is asking you to remember when you raise a power to a power, you multiply, and if you multiply 2 square roots, the roots fly off, so it's 3 to the 5th, which is 243. I had to use my calculator real quick. This one here, just start out by the square root of 16 is 4, and then cube it, and you get 64. This one is just asking you to go power to a power, power to a power, which means multiply, multiply. What's 1/3 times 3? Well, that's just 1, so it's just a to the first, b to the first, which is just ab. This one is asking you to remember Pemdas, so do anything in the parentheses first. So that's just the same thing as the square root of 16. That's the same thing as the square root of 9. So that's just 4. That's just 3. 4 plus 3 is 7, so it's really 7 squared, which is 49. Now this is asking us to find an angle that's coterminal with 225. Coterminal means it stops in the exact same spot. So 225 would be 180 plus 45. So this is 45 right here. So if this is a multiple choice test, we got to be looking for a positive one, and we better be looking for a negative one. So I give you both of them. But if I want the positive one, that means I got to continue in this direction, get to here, and then go around another 360. So I would go 225 plus 360, which is 585. But if I wanted to find the negative one, I would start here and just go down, which would mean 90 plus this 45, which would be negative 135. So this might be what you're looking for. This might be what you're looking for. So I've already got things drawn for you. It says an angle theta in standard position. So there's our theta. That means your reference angle. Remember, it's got to be sandwiched between the x-axis and my spinner. That's very important. So it says find the value for sine. Well, sine is opposite, as you can see right here, over hypotenuse. So we got to find the hypotenuse. This is not a special type of triangle, so I need to go a squared plus b squared equals c squared. That's 25 plus 4, which is 29. So I can see that my hypotenuse is the square root of 29. What would sine be? Opposite over hypotenuse. That'd be 5 over the square root of 29. Now, we got into the habit of getting that radical out of the denominator, so let's just stick with that. And there's sine. Cosine is adjacent over hypotenuse, and if that's my reference angle, that's my adjacent, that's my hypotenuse, so that's negative 2 over the square root of 29. Get that square root out of there. Negative 2 square root of 29 all over 29. Tangent, by definition, is opposite over adjacent, so I find my reference angle. Opposite over adjacent would be 5 over negative 2. Typically, they put the negative in the top. Either one of these is fine. This is changing it up a little bit. This is saying find the exact value of cosine of 300. You could type this in your calculator, but it's going to give you a decimal, and all of your multiple choice options will not be decimals because the problem wants you to spin your spinner 300 degrees, so it goes all the way 270 plus 30. Then you'd realize, wait a minute, this is not my reference angle, this is. So that's 60. And if I finished my triangle by going back to the x-axis like we always did, now I've got this little sneaky 30, 60, 90. If I remember my rules, this is my 1, this is my 2, this is my square root of 3. The only one negative in that bunch is that, because that would be considered right and down. So this has to be negative square root of 3. It says cosine, which is adjacent over hypotenuse, which would be 1 over 2. 49, we've got 2 problems left, you guys. It says express cosine of 210, so we better take a look at that. First of all students take calc. 210, where does that take us? Well, up 90, 180, plus another 30 would land us in the third quadrant where tangent is the only thing positive. That means cosine is going to be negative. So we can take care of that right now. The question is, what would our new reference angle be? Well, I kind of already told you. This is 90 and 90 and 30. So there's my new reference angle. So that's what I'm going to replace it with, 30 degrees. But it would be negative in the third quadrant because of all students take calc rule. Also, you can just look at it and say, what would cosine be? Well, that's adjacent. This would be negative over hypotenuse, and hypotenuse is always positive. So it makes sense. Last problem, congratulations. So it says, given the point 5, 12, that means go out 5 and up 12 and get a point. Find cosine. Well, cosine is adjacent over hypotenuse. I'm going to draw in the spinner, which is my hypotenuse. If you remember geometry, 5, 12, 13, if you don't remember that, you'll have to go a squared plus b squared equals c squared, and you'll eventually get 13. Now here's my reference angle. It says find cosine, which is again adjacent over hypotenuse, adjacent over hypotenuse, 5 over 13. Good luck on that exam.